Our project was the Golden Bite Mouthguard strength testing device. So Dr. Quigless designed the Golden Bite Mouthguard to improve its users' strength, balance, and flexibility by means of proper jaw alignment. He claims that the mouthguard is able to improve athletic performance by up to 30%, but needed a way to quantify that assertion. So we designed a portable device to test an individual's strength to be used both in office and at conferences he may attend, even for potential future clinical testing. Our device measures both compressive and tensile loads applied to it over a period of time and outputs those results digitally and graphically.
So the Golden Bite Mouthguard is intended to improve performance, and our customer is Dr. Kirk Quiggles. The design problem is to find a way to measure the mouthguard's effect on athletic performance. So we want to design a device that he can then take to his patients or users of this mouthguard and then provide feedback on how this device works.
So at the beginning of the semester, the first thing we did was we held a meeting with Dr. Q and came up with a list of user needs that he wanted. And you can see this list right here. He needed something that was portable that he could take to different athletic facilities, gyms, football fields, etc. It needed to be a tabletop application, basically, that fits in with portability. It just needs to be able to fit on a table. It has to have concrete data acquisition, a digital readout as opposed to analog acquisition. It has to handle a range of users. So there could be, for example, if he takes it to a football team, you could test on a lineman. You could be able to test on a gymnast. Different body types need to be able to use this. It has to be easy to use, durable, it can't break, and it has to have a variable load, which takes away the user bias. For example, if you put in the mouth guard, you may subconsciously push harder or increase your performance without knowing it. So there has to be a way to take away that bias somehow. And you can see in the top right, this is our initial prototype sketch that we were going to pursue. And then in the bottom right, after we were faced with the variable load idea in the middle of the semester, we had to come up with a different design. So in the bottom right, you can see the CAD drawing of our final product. Then this measures strength. That's the design metric.
So now we're going to take you guys through a video of the prototype functioning. This is a close-up view of the product. You can see the spring damper system there, and they're adjustable with threads individually on each one, which gives you a range of possibilities for a variable load. And there's a load cell and another handle, a data acquisition board, a signal amplifier, and data acquisition software. So now we will show you a kind of a live stream demo, so you'll be able to see the data picked up by the computer. There are two different main ways to compress the device. These are just the first two we use are horizontal and vertical. Vertical does a little more balance testing. So if you can see, it's kind of faint with the lighting, but there is readout going to the computer, and you see peaks and valleys plotted, which is the output voltage from the load cell. And that is then converted to pounds with the load cell calibration that we did.
Given more time, we'd like to make a few small mechanical changes to the device, including the sliding mechanism Right now, it's a threaded rod, and we think that it would be best to remove those threads. We also would like to add a mechanism to more quickly adjust that variable load so that it could be done between tests without the user noticing. Furthermore, we'd like to automate the data collection so that a real-time force output could be read by the user. And this we would do using an Arduino board so that we could convert the voltage from the load cell to a force automatically. We did see an 11% increase in force output using the mouth guard, and so we think that it would definitely be worthwhile to pursue clinical testing or even take this device to conferences, out to the football field, and test it on a number of Dr. Quiglis's patients and customers. Thank you.
One question then?
You think 11% is statistically significant? Did you need analysis to see?
It's hard to say because we designed the product. So any test that we do is subject to a little bit more bias than even the user bias who knows about the mouth guard. So while we saw that, it's hard to say if you tried on someone who
Well, it has to be
hasn't.
how many people you tested, standard deviations,
So,
R factors.
That's why we would suggest that clinical testing should be used.
And Dave, also, a more control.
More control.
With a known load is what planned, but it was beyond scope.
No, I just wondered.
All right, thanks, guys.
Okay, one last thing real quick. I just want to thank Dr. Quiglis, he's in the back of the room. Thank you.